I will record it now. That's bound to have happened. Sorry about that. But you've got all of the, you know, we haven't even talked about the topics yet that we're going to talk about. So you've got information in chat. You've got information. The chat should be available. I can, we can talk about that. I think you're getting a lot of good information, and really we've just been having a Q&A. So we're really not talking about any topics now. Thank you for reminding me to turn on the recording. Now I see you are recording. So yes, Luke, you are allowed to use those other 2 sheets of paper for the non-written portion, but you're not going to turn those in. Those are not going to be turned in. That's just for you. Okay, thank you. That's good. Feel free to double check. I double check things all the time. You don't have to have just a wall behind you. You can, the background's okay, whatever background it is. In fact, I like seeing things in the background. It makes it more fun for me to look at those proctoring logs, because let me tell you, it can get pretty, it's just, you know, I've got a really, it's just pretty tedious work. So I like seeing something interesting in the background. Okay, so let's start by going down and looking at, there was one topic that we did not quite get to in the more on functions objective that is due on Sunday. Let's do that topic first. So I appreciate all of you. Thanks for the great questions. I want to make sure you all understand what's going on with the testing, and I knew it would take a bit of time, but I wanted to give you that time because I think it's so important, because doing all this up front is going to set the tone for the rest of the semester and how it's going to work. So the only topic that we did not get to on more and functions last time was this topic on finding where a function is increasing, decreasing, or constant. Determine the intervals on which the function is strictly decreasing. Strictly means even if the endpoint is included, we're going to use parentheses only in a no interval notation, no matter what. That's what that word strictly means. And I know it's confusing, but you have to have the word strictly to always just use parentheses. Otherwise, you got to use those other rules. If an endpoint is included, you have to use a bracket. It's only if you've got the word strictly that you can always use parentheses. Otherwise, you just have to go by the rules that we talked about before. And to briefly show you those rules that we talked about before, let's go back here. We looked at this last time. So these are the rules. Parentheses, in general, for almost all the problems that you're going to do in math ever, these are the rules. Parentheses, when it's negative infinity, positive infinity, endpoint is not included, or you have an open circle. And I didn't take the time to write down those over there, so let me do that. You might want to put these down as well. You've got a less than sign or a greater than sign. Okay, so those are the rules. Parentheses, use parentheses. In general, use parentheses when you have, I should call this the default. And almost all the time, you're going to be using the default. Use parentheses when you have negative infinity, positive infinity, the endpoint is not included, the circle isn't colored in, and the equal indicator of these inequality symbols is not there. Use brackets when the endpoint is included, you have a colored in circle, or you have greater than or equal to or less than or equal to. And feel free to take screenshots. I take screenshots all the time. I think you probably have noticed that I'm a big screenshot lover. They come in handy. So if you want to take a screenshot of this, feel free to do so. I'll give you just a quick second. If you want to know on a Mac how to do it, I can tell you that. I have been dabbling with the Windows computer a little bit lately, but I haven't used a Windows computer in 10 years, really. So let's go back to what we were looking at. And I saw that problem go by. There it is. It's because of this word strictly. When we use that word in math, we only use parentheses, no matter what. And that's with respect to interval notation. So what are we looking for here? We've been given a graph. And here's the graph. It goes like this, like connect the dots. What are we asked to do? Determine the interval or intervals on which the function is strictly decreasing. That means the y values are going down as we go from left to right. So let's start. We always go from left to right. So I'm coming in from negative infinity. The first place I hit the graph is right here. And then the y values are going up because the y value of this point, if I go straight over, is -5. And if I go up to, say, -4, it's higher up. So -5 is right here. -4 is higher. So I'm going up in y values. When we talk about this topic, where we're looking at where is the function increasing, constant, and decreasing, we're talking about the y values. What are they doing? The y values are increasing, getting larger when we go up, when we climb up a mountain, let's say. So in this part of the graph, the y values are increasing, getting larger, which is the reason why I have an upward pointing arrow here. Then we get right here, and then we have to turn, and we are going along a flat spot, and in that from here to here, if you trace any point over the y-axis, you're going to get -1, no matter what point you pick in here. That means the y values are constant. In this region of the graph, the y values are constantly -1. So the flat part is where this function is constant. Here's another part. We're now going up, like up a mountain. That's where this function is increasing. The y values are going up, and you can see they go up over here. We then get to another flat part. That's where the function is constant. And now we're going down, down, down. The y, that means as we go down, let's take a look at this point. It's at 3. And if we go down to, say, here, right here, that's at 0. So we went down from 3 to 0. So it's going down as we move from left to right. So
I have a question.
Yes.
Okay, so if the problem is ever asking, like, at what points is it constant, would you put both of those, like, both of those constant intervals?
We're going to look at finding the intervals in a moment. I just wanted to explain the graph. Okay. That's good that you're looking ahead, though. Very good. Okay. So what are we asked to find in this problem? Determine the interval or intervals at which the function is strictly decreasing. How many places is this function decreasing at? Who can tell me? How many places of the graph?
How many? Looks like just one.
Just one. That's correct. That's correct. Right here, there's just one place where this graph is decreasing, where the y values are going down. And that's why I like to label my graph decreasing. Values are going down. And that would be from, it starts decreasing right here at this point right here. which is at 3. If you go straight over it, well, sorry, it's the y. So when we state the intervals, we're using x's. Okay, so when we want to know what the x coordinate at where it starts decreasing at, we want to state x coordinates. Very important. We state x coordinates as we state when we state any of our. So we need to make sure that we are clear. That's what we're looking for, what the y values are doing. Are they going up or down or remaining constant? But when we state our intervals, we are stating the x's. So let's the x coordinate of this point right here is at 3. And that's the reason why there is a 3 right here. Now, the endpoint, there is an endpoint, but remember, we are talking about strictly here. So we use parentheses only in interval notation, no matter what. So we want a parenthesis here. And then we want the number, we want 3 and all the numbers in between 3 and we're going down, down, down. The y values are decreasing until we get to x coordinate of
7.
Great, yes, 7. And then we're using parentheses because that's what we use when we see that word strictly. We always use parentheses. So that's all it asked for in this particular problem. But let's take a look at what's strictly increasing. What would we do there? Strictly increasing. That increasing means the y values are going up. So we've got this region of the graph and this region of the graph. And we want to look at the x values. So this point here, where we start, where the y values start increasing, if we go straight up, we get to -5. Now, strictly means we use parentheses only. So we want all the points from -5 all the way to, go up here. That's where we stop going up and go flat, and that goes straight up to the x-axis, and that's at -2. And then Alex in the directions up above says to use a comma if you have more than one interval. Separate each interval with a comma. So the other one that is, we have another interval where the y values are going up. It's right here. Starts right here, and we want the x coordinate of that, so we go to the x-axis to get it. That's at 0. 0 all the way to, go straight up this point, and we want the x coordinate, go straight down to 2, and we get this, and we're only using parentheses. Now we can do the same thing with strictly constant. That means flat. So we have this interval straight up to -2, straight up to 0. So it's from -2, it's -2 comma 0 with parentheses around it. Comma, that's Alex wants a comma in between. This other interval, that's right here. We go straight down and we get 2. Go straight down here and get 3. That's from 2 to 3. Of course, with a comma in between. Any questions on this particular topic? So you're only, we were only asked to do strictly decreasing for this problem, but I wanted to do the others too so you could see the differences. So you could be well armed to do any of them. That concludes what we want to talk about on functions. Does anybody have any questions on this particular objective, which I believe is due Sunday night? So now let's talk about the written work topics, the 7 written work topics. Let me go get that document. And remember from the beginning of class, these are actually in instructor resources. Did I show you instructor resources in Alex? I don't remember if I might have forgotten to do that. So in Alex, if I go back in, takes a little while, but I want to show you where they are. Picture is worth 1,000 words sometimes. These 3 bars, we did talk about those. That's called the main menu. We talked about assignments. Gradebook, that's where you go to see your grades in this course. Those grades match my grades in my gradebook that I see for you. You do not want to, assignments could be inaccurate. So you definitely want to look in the gradebook for your grades. Instructor resources. So instructor resources, test reviews, test 1 review. Test 1 review topic selected by Ann Baird. That is what I am looking at today. That's that document. I've got that exact document already downloaded and set up here for us to look at. So let's take a look at these. And I'm going to start with topic 1. Now, with written work, I don't really care that much about the answer. There's the problems have been selected, so I'm looking for different steps. I'm looking to see if you know how to simplify this, so that's what I'm looking for. I'm looking for if you know how to write down the work. Part of this is writing down the correct work as well. So that's what I'm looking for. That's why I have struck a happy median, a happy place with my students where, hey, you've got half the test where you can, I am answers only, and half the test where I'm requiring written work and grading the written work. So there's other things I'm looking for. I'm not really looking for the answer very much. I'm looking for the process. You quite possibly will use some of these processes in the future. You're not going to use the answers in the future, unlikely. So that's where I am coming from where I sit. And some of these processes I'm testing here because I don't want to give you like 30 questions or whatever. So that's where I'm testing them. So the first thing we want to do is we've seen all of these topics before in this class. I've talked about all of them in our remote class before. So we want to simplify this expression. First thing you want to do is look at the square root. So we want to break 75 down. What's in this 75 here? We want to break it down. 5 goes because it ends in a 5. So if I take 75 and divide it by 5, I'm going to get 15. Take 15 and divide it by 5, get 3. So I know the roots are 5, 3. The roots of this tree are 5, 3, and 5. So I'm going to take out the 75 and put in these roots. I'm going to write the 5s next to each other and then the 3. And they're all multiplied together. So if you know at this point, if you know that 2 of the same comes out as a single one, you could skip straight to this step. If you prefer, you can take these 5s and multiply them together to get 25, and then remember that the square root of 25 is 5. And then we've just got to keep the 3 inside because it's a prime number. So square root of 75 we can write as 5 times the square root of 3. So we're going to take the square root of 75 out and put 5 square root of 3 in its place. Meanwhile, we're going to break down this 15 into 3 times 5. and break down this 35 into 5 times 7. Now what do we do? You don't want to cancel this 5 with this 5 and be done and say it's 8 minus square root of 3 over 7. That would be incorrect. We cancel we spend so much time in math talking about factoring because we can cancel factors. We cannot cancel terms. This is adding a negative here. So we really, this is 15, let's say, plus a negative 5 square root of 3. So the term is really negative 5 square root of 3. If you look at it as like that, so you can't cancel you can't cancel a term. So I can't cancel this with this. We won't get the same answer. You can do it, you can work it out and see that it won't give the same answer. So I'm looking to see if you know the right processes, if you know that you can't cancel terms. That's what I'm really looking for. And I want you to know that you can cancel factors. So where do we go from here? We're down here. So if you notice, this is a term, and then plus sign, negative 5 root 3 is a term. You can factor out of terms. So we factor out of terms. There's a 5 in this term and a 5 in this term. We can factor that 5 all the way out front. When we factor that 5 all the way out front, that 5 goes, but we're left with the 3. Copy the minus sign over. That 5 went out front. We're left with square root of 3. And now, what do we have? And who can tell me, this is a great question, who can tell me why I can cancel these 5s? What allows me to cancel those 5s? Why can I cancel the 5s other than I
Because both sides can be divided by 5.
So we don't have both sides because we don't have an equal sign here. But I'm glad you brought that up. Why? What is 5 divided by 5?
Isn't it 1?
Yes, exactly. And 1 times what's left is what's left, correct?
Yes, ma'am.
So that's why you can cancel those 5s. So I encourage you to understand why you can cancel, because it'll help you make less errors. So what we are left with now is 3 minus the square root of 3 over 7, and that's our answer. So we're done. Any questions on this particular topic? So let's go on. Keep an eye on the clock there. Oh, this is cool. So we had fun in our class last time. Find the roots of a quadratic equation with leading coefficient not equal to 1. So solve for v. 9v squared equals 30v minus 25. So I want to get everything on one side, and it's important to keep the leading coefficient, the number in front of the squared term, positive. It just makes life a lot easier. So I'm going to move everything to the other side. Everything on this side to the other side. So that would mean we'd get 9v squared. This is positive on this side, goes to the other side is negative, 30v. This is negative, goes to the other side is positive, 25 equals 0. Then I said to my class, well, now that you've got this set equal to 0, there are 2 ways to do it. You could either use factoring. Do we want to really factor? We've got a coefficient of 9 here. Or you could use the quadratic formula. And let me just take a peek real fast and see if I could pull up that slide that I had today. That class went from 10 to 11:50. Let me see if I can find that screenshot really fast. I don't remember if I can find it fast. So let me see if I can, because I would like to show you something. I think I took, yes, there it is. Does everybody see that? I did a whiteboard demo for them. Since you all have my notes, you can see how I did it via factoring. I want to show you that if you have a quadratic expression on this side equal to 0, you also can use the quadratic formula. Turns out the quadratic formula probably would be the way to go for this problem. So we did this in my last class, in my first class of the day. So I just copied over the exact same problem that we had before, except I put everything on one side and made it equal to 0, which we just did anyway. So I wrote down the quadratic formula. I forgot to put 2a here, so forgive me. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. I don't want to cram a 2a in there. No telling what would happen if I did that. And I can't even use these anyway because I'm using a screenshot. So let's use a quadratic formula. Quadratic formula has a negative sign. We've got it written in descending power order. Power of 2 understood power of 1 and constant. So negative goes right here. B. B is the coefficient of the middle term. Goes in ABC order. Negative 30. Plus or minus the square root of B. B is negative 30. So I have negative 30. Put it in parentheses. Very important to do that or you're likely going to get the wrong sign. And then square it. Minus 4. Minus 4 just gets copied down. A. A is 9. And and then we have C, which is 25. All over 2, that's part of the quadratic formula. A, which is 9. Now you will see, and this won't get recorded. Unfortunately, the whiteboard doesn't record. At least if it does, it's some news to me because it didn't this summer. Now I want to simplify this. So the first thing that we do that I like to do to simplify is just figure out what's going on inside this radical here. So if you grab your calculators and you take negative in the bottom row of the calculator, let's do parentheses first. Do parentheses first. So I literally want to write it as I've got it written in here. At parentheses, negative bottom row of the calculator, 30, parentheses. The key above the division sign is a mountain. It's like a mountain peak, looks like a mountain peak. That's going to raise it to an exponent. And in the exponent I want to put in is a 2. Right arrow down, minus 4 times 9 times 25. And when I hit enter, I get 0. So this right here, this square root is actually the square root of 0, which turns out to be 0 because I can take 2 zeros and multiply them together to get 0. So I would have 2 zeros under here and I could take it out as a single 0. So I thought that's much easier, I think. It depends on your preference. I would not want to factor this if I didn't have to. So we just need to clean things up. We get negative times negative, which is positive 30, plus or minus 0. All over 2 times 9, which is 18. 30 plus 0 is 30. 30 minus 0 is 30. So either way, we're going to get a 30. And then we have an 18 down here. Now you'll want to reduce this. I would math frac it on the calculator. Put 30, division symbol, 18. Go to the math key in the first column. And then hit enter, enter. Converts to a fraction, got 5/3. So this doesn't appear unfortunately, in the video of this course today, in the recording. That's a quirk that I hope Microsoft fixes at some point. So if you want to take a screenshot, you can. On my Mac, it's Shift Command 3. That's what I just pressed to get that clicking sound. Any questions on this particular topic? So I just thought I would show that to you so that you could see a different way of doing the same problem. Any questions? So if somebody likes this way of doing it, it's honestly a lot easier. I think it is too. So maybe for this topic, feel free to try it and see if which way you like the best or which one works for you better. Only works for quadratic equations though. So let's see what else we can take a look at. And you see, what do we get? We got 5/3, the same answer. You can do it this way if you want, whatever you're most comfortable with. So there's more than one way to do problems and to do them correctly. So let's take a look at the next one. Let's look at number 3, which is on the Pythagorean theorem. And this may be our last one of the day, but we've still got Tuesday's class to go over some of these written work problems. So the shorter leg of a right triangle is 60 meters shorter than the longer leg. The hypotenuse is 6 meters longer than the longer leg. Find the side lengths of the triangle. Well, first of all, we have a right triangle. So I drew the right triangle. Secondly, we're told that we're talking about hypotenuse and legs. So we know that we use the Pythagorean theorem, a squared plus b squared equals c squared. This means a leg squared plus the other leg squared equals the hypotenuse squared. So the hypotenuse is the longest side. The sides that form this right angle, those are the legs. So let's reread the problem and see where we are at. So the shorter leg of a right triangle is 6 meters shorter than the longer leg. The hypotenuse is 6 meters longer than the longer leg. So we're being told information about the shorter leg in relation to the longer leg. Here we're being told information about the hypotenuse in relation to the longer leg. So it's that longer leg. Which one of these is longer? This one that we want to let be x. So in this problem, it's the longer leg we want to be x. Not necessarily true in every problem that Alex is going to give you for this topic. So if this had said shorter leg here and shorter leg here, then you'd want to let the x be the shorter leg. In this case, it's the longer leg. So now the shorter leg, the legs form the right angle, so that would be over here, is 6 meters shorter than the longer leg. So it's the longer leg, whatever the longer leg is, which is x, and it's 6 meters shorter, so we need to subtract 6 to make it less. The hypotenuse is 6 meters longer than the longer leg. So we need to take the longer leg, which is x, and add 6 to it. And that's what I did here. Now it's time for the Pythagorean theorem. I just wrote in these numbers. These are the answers. So we'll get back to these as soon as we get to the answers. So we're going to take one leg squared, and it doesn't matter which one of the legs you do first. Addition is commutative. So it means you can add in any order you want. So you can take either leg and go first. X minus 6 squared, x minus 6 in parentheses squared, plus the other leg, which is x squared, equals the hypotenuse, which is x plus 6 squared. using parentheses when you have 2 or more terms. Now we want to deal with this and deal with this. This 2 tells us we want 2 of this base x minus 6 multiplied together. That's what it tells us. So we've got 2 terms times 2 terms. We can FOIL those. The first 2, x squared. The outer 2, x times negative 6 is negative 6x. The inner 2, negative 6x, for a total of negative 12x. Negative times negative, positive, 6 times 6, 36. So I'm going to take this guy out and replace it by x squared minus 12x plus 36. That's what I did. Over here, we do the same process with x plus 6 times x plus 6. So FOIL, x squared plus 6x plus 6 more x is plus 12x. 6 times 6 is 36. Wrote that over here. So now we want to just get everything on one side. Now I first looked at both sides and say, hey, we've got a x squared on both sides. And if I subtract x squared from both sides, those would both go away. So I just cross them out. Now what's left? This side has an x squared on it, so I'm going to move everything to this side. The opposite of adding 12x, subtracting 12x, opposite adding 36, subtracting 36. What we do to one side, we need to do to the other side. So I subtracted 12x and lined it up with the x's over here, subtracted 36, lined it up with the constant over here. So this is going to sum to 0, this is going to sum to 0, and all we're going to get on this side is 0. Over here, we have minus 12 more x's for a total of negative 24 x's. 36 minus 36 is 0, so we don't have to add that, but we have plus x squared. I'm going to put that out in front, and that is equal to 0. We now want to factor this. So there's 2 x's in this term. Terms are added. You could sneak in a plus sign here to see that. And this term has an x. So this term has 2 x's. This term has 1 x. We can factor one of the x's out front. That would mean from here, we took one of the 2 x's out. We still have an x left. Minus 24, this x went out front. And you could always go backwards to check. X squared, check. X times negative 24 is negative 24x, check. Equals 0. So now we set each factor equal to 0. There's an understood multiplication symbol here. So we just have x here, set it equal to 0. Have x minus 24, set it equal to 0. Solve for x. This one is already solved for x. X here represents the length. It represents, to be precise, x represents what? That represents the length of the longer leg. There's no way the length of the longer leg could be 0. We wouldn't have a triangle at all. So we cross this out because it doesn't make sense in this context. Now we solve this equation. X minus 24 equals 0. For x, undo subtraction, addition, add 24 to both sides, and we get x equals 24. So the length of the longer leg is 24. So that's why I put a 24 here. That means I plug in 24 here for x. 24 minus 6 equals 18. Plug in 24 here for x. Get 24 plus 6 equals 30. That's where those values came from. And then I just put them in their appropriate spot up here. The length of the shorter leg is 18. The length of the longer leg is 24. The length of the hypotenuse over here is 30. Any questions on this particular topic? Well, I don't have time to do another topic. I do want to, however, take attendance. Our time is almost up, so let me quickly take attendance. And I want to go to the participants to do that. And I will take a couple of screenshots. And then I want to just tell you, this is a great class. I like all your questions and participation and so forth. Reach out to me if you need anything. Stay safe and well. If you're not feeling great, I hope you feel better soon. Take care and have as nice a weekend as you can. See you on Tuesday. Bye for now. And you're welcome to stay around. I do have office hours. I can answer a few questions after class if you want to stay around. But if you want us to talk too long, we'll have to hop into my office hour meeting. Feel free to leave the conference. Feel free to stick around if you've got a question or two. Olivia, do you have a question, or Brian? You have any questions?
Yeah, I have a question.
Yes.
So for one of my assignments, it's still showing up as a really low grade, but I did the assignment that was due early and went back and redid the other one, but it's still showing up a low score. I don't know if that gets changed or.
So I would need to know more detail about your situation. It would be very hard because I would have to go and research it. So can you tell me what the particular, let me first just jot down a note. So I want to get your name down and I can see your name on the screen there. So that's good. So what objective are you specifically talking about that you think you didn't get the credit for? And which topic? And you're welcome to send those to me. So I would need to know the objective and the topic title, like for instance, a topic is solve a quotient involving a sum or difference with a square root. Otherwise, it would be very hard for me to troubleshoot. I feel like I would be looking for a needle in a haystack.
Yeah, I think I wrote down that it was the rational equations assignment.
Okay, so which one of the rational equations, though? There are several.
Let me go. I'm sorry.
No, that's okay. Go ahead and look. Brian, do you have a question in the meantime? So I'll try to go and look for you. So let me see if I can find what I can find on my end. But I do have to get out of here in a few minutes, and that's because I've got my virtual office hours aren't in this particular team. So I will let me look here.
It's like you were saying how you see the grades that are in the grade book, not in the assignments.
Correct.
And at assignments, I see 100% because I went back and redid it. But on grade book, I still see a low score from before.
Right.
And it was
I understand, but there's no way for me to see what you see in your grade book. So I would need you to take some screenshots and send them to me and explain what the screenshots are of. It's really hard because I can't see that. You know what I'm saying?
Yeah.
That's what I'm saying. So I have office hours here in a couple minutes, but let me just go in because we're the only ones. Let me make sure we're the only ones in here right now, and we are. So let me go into, I will have to stop sharing my screen to do this, but I can do that. And let me turn off the recording too.